electricity and sent onto this cable. So that's really what this means. Yeah, we got data sitting on this PC. We got ones and zeros. Think about it. We got ones and zeros. But we got to take these ones and zeros and we got to turn them into electrical signals. Electricity. That's what we have to turn it into. And Ethernet makes sure that that information on this side is being put on the wire a certain way because it knows on the other end of this cable it's going to be another Ethernet device. And guess what? That Ethernet device is going to need to read the information that's coming across this cable. So don't you think it'd be nice to have another Ethernet port over here that follows the same rules? There you go. Otherwise, if they follow different rules, we have the Wild Wild West, and you have a lot of PCs not being able to communicate. So this is Ethernet in a standard, in a simple form. You can go as deep if you want as internet, as Ethernet, but at the same time, I'll leave it to you to make that decision. So now we get to talk about types of Ethernet. Because we might have Ethernet, but it would be nice to have some types of Ethernet that we're going to discuss here. So Ethernet has several types of these different speeds and different distances that we can actually send data across. So when we talk about Ethernet, really, we're talking about 10 megabits per second. This 10 base T. So let's talk about what this means. The 10 is your speed. The base is just telling you, look, this is just 10 base. This is telling you that we can send data up to 10 megabits per second. Now let's talk about this because our megabits per second means something. A bit is either a 1 or a 0. Okay? It's either 1 or a 0. All PCs communicate with 1s and 0s only. The 1 will mean that it's on, the 0 means it's off. It's just a series of possible combinations. So if I have a light switch, let's kind of throw this light bulb here. If I have this light switch here, I will say a button. How about better that? Let's use a button. Make my drawing a lot easier. If I have this button that I push, let's say this is actually going to ground. I have this power source here. We'll say it's a battery. This will come to my negative. And this will be my positive. And this button is nothing more than a switch. So when I push this button, the power that's normally off turns to on. Well, guess what? When I push it and it's on, it's a 1. If I turn it off, it's a 0. Okay, pretty simple. I have two possible combinations. 1 or 0. Now, if I add another switch or another button here, and flow this through here, and we're going to have 2 here, and go up through here. Let's think about how this works. And I'm not going to get too technical here. But if I push this button, if this button is on, and this button is on, which means maybe in the down position, because you're pushing a button. If you push it on, the button will be down. And if you push it off, the button will come out. But if I had this on and this on, the light bulb comes off. It will be on. That's a combination. That gives me a 1. If I have this on and this off, then that gives me a 0. That's a second combination. And if I had this off and off, this might be on. And that's a third combination. Does that make sense? Imagine having these buttons as with thousands and millions of possibilities. We call them transistors. Circuitry. Okay? So your output is either going to be a 1 or 0, and we use this ability to give you all the output that we get. All this magic is done by 1s and 0s. So a bit is either a 1 or a 0. You don't need to understand fully the magic. Just understand that a bit is 1 and 0. If I have 4 bits, we call it a nibble, which is most likely you won't be seeing often. If we have 8 bits, we call this a byte. So a byte equals 8 bits. If I say I have 1 byte, that means I have 8 bits. If I say I have 8 bits, that means I have 1 byte. But everything we do in the networking field is bits. Everything is bits. So now, what happens if I have 100 bits? Well, nothing really. But if I have 1,000 bits, that equals a kilobit. Now, this could transfer into bytes as well. If I had 1,000 bytes, it would be a kilobyte. But we're talking about bits. In the networking field, in our world, it's all bits. But for storage, you can look at bytes, gigabytes, terabytes, brontobytes, whatever you want to talk about, zettabytes. But here, we're dealing with bits. So we're going to say 1,000 equals a kilobit. That means now I have 1 kilobit. 1 kilobit. Now, if I take 1,000 kilobits, that's going to equal a megabit. You're starting to see what's happening here? So if I take 1,000 megabits, and notice that B is small, then that would equal 1 gigabit. Now, if this was a big B, a capital B, it would be bytes. So if I was over here and I said, okay, I'm going to take 1,000 bytes, that's going to equal 1 megabyte. So this is how we actually identify our information and how much data is actually going from one spot to another. We use this as a means of measurement. I mean, that's really the way we do this, and our measurement is measured as speed. When we say a car is going 60 miles per hour, we're saying about at the speed that is going right now. The speed that we're going right now. I got that all backwards. Give me a second. 60 miles. My brain's not working today. 60 miles per hour. We're saying that, look, at the rate this car is going, in an hour's time, it would have gone 60 miles. A lot of people use this as a sense of speed. Oh man, he was flying. He was going 60 miles per hour. But really, it's a term of distance, right? Or is it both? some scientist says you can't have space without time. You can't have time without space. You can't have time without distance. So space-time is what we want to call it. Same concept here. Here, we're going to say 10 megabits per second. We're not really measuring distance here. We're measuring how much data that we're moving per second. And this relates to us as speed in a lot of fashions because we want to know how fast we're getting our data. I mean, that's really the bottom line, right? So a 10-base system is saying, look, the base of this speed is going to be 10 megabits per second. And that means we are going to be sending this data over twisted pair cable. Now, what does twisted pair cable means? It means that the cables that we are using to send the data over is literally twisted. We have 4 pairs in there, in each pair, or 8 wires, and we twist 2 wires together with so many twists per inch. So if we take a look at this cable here, and look how we're really twisting this cable. This is how it's going to look. Now, this one has so many twists per inch. Same distance cable, but we got a lot more twists per inch. So twisted pair, we literally twist these cables that are inside the jacket. Now, the purpose of this is to eliminate magnetic fields and to lower the power of the magnetic field. This one has more twist than this one that's sitting right next to it. Their magnetic fields will not be able to sync. The twist will do 2 things. One, the twist will lower the magnetic field, will limit it, so instead of being out to here, kind of like out here, it might only be out to here. So it limits our magnetic field. And the reason why we have multiple twists, this one will have different twists per inch than this one, is so these magnetic fields don't kind of like bond up into the same frequency and just become one big magnetic field. That's the whole purpose. Because otherwise you're going to get data corruption as it's going across the wire. This is electricity. Electricity creates a magnetic field as it's going through the cables. Okay? So when we have Ethernet, Ethernet really means that we're doing 10 base T. And it really means that we are doing 10 megabits per second. That's really the concept of Ethernet. So when I say Ethernet, I use it in the terms of just talking about Ethernet itself. We're running it over Ethernet cable. Or we're running over Ethernet, which means I'm going to be having Ethernet ports, Ethernet cables, which would be Cat5 or Cat6 cable. But really what I should be meaning when I say this is 10 megabits per second. But that's not the case. We use Ethernet interchangeably. Now, if I want to go to fast Ethernet, that's a different story. Now, notice these are my IEEE numbers. You can memorize these if you want. I don't spend the effort of memorizing all these numbers. And fast Ethernet, and you will actually see on your router, you'll see either Ethernet or fast Ethernet written on your port. When you see it say fast Ethernet, that means that port has the ability to go up to 100 megabits per second. It doesn't mean this is what you're getting consistently. It means it has up to 100 megabits per second. Now, I can go up to 1,000 megabits per second or 1 gigabit per second. And I can do the 1 gigabit per second either on twisted pair or fiber. And then, of course, I have up to 10 gigabits per second and 40 gigabits per second. Most likely, yours is only going to be doing 100 megabits per second, which is all you need. I mean, technically, you only need 10 megabits per second for your labs. You don't need speed. I remember sitting there I was actually turning on a clock speed for a router, and I turned it to 64,000. I was like, why would you do that, man? Turn that thing all the way up. I'm like, why, man? Those pings, it doesn't matter if the pings take, they're so fast. I mean, I probably get 5 pings within a second. Maybe 2 seconds. I mean, do I want to get it in 0.80 seconds? I mean, does it really matter to me? So I never really cared about the speed. I mean, you could. Doesn't really matter. I personally like the lower speed because on the very high speeds, I could do 10,000 pings like that. I don't want to. I want to be able to send 10,000 pings and have it run long enough for me to be able to make changes on the end if I want to see if it affects my pings. So these are your Ethernet types. And this all depends on the port that you're using and the technology you're using. How do we determine this? Well, obviously by the chipsets that we're using, by the circuitry that we're using, and we give these circuitries names. When you have one flash drive that only has 4 gigs, isn't it different technology when it's the same size flash drive, but can do 8 gigs? Well, these would be gigabytes. I mean, same thing, but one's 4 gig and one's 8 gig. It's different technology, and we might call this flash. We might call this fast flash. Make sense? That's what we're doing here. Most likely you'll be dealing with fast Ethernet. The 2950s, those are fast Ethernet. The 3550s, 3560s, those are fast Ethernet. So, but it's nice to know your Ethernet types and that they exist. Now, this one is talking about our cables. Now, remember, we need cables in order to plug our devices in. A lot of people call them Ethernet cables. And whenever we think about Ethernet cables, we have a category type of cable. This is what this cat means. It means category. So if I have a category of 5, that means this is the minimum cable that I need in order to run Ethernet successfully. And you can see I have cat 1, 2, 3, and you can see they're all for telephone. So it wouldn't be a smart idea to take Ethernet and try to run it over a telephone wire. You might not get guaranteed delivery. You might not get good communication. You might find yourself having all types of weird issues. This would be token ring. Notice that we have Cat E. Cat E gives us the ability where Cat 5 only gives us up to 100 megabits per second. We can go to Cat E and give us 1 gigabits per second. Now, you got to ask yourself, what's really the difference between Cat 5 and Cat E? You really want to know the truth? Really, the main difference is twists per inch. A Cat 5e cable will have more twists per inch.